Hi all, thank you for your participation. My name is Vijay Gunchi and I am an alliance partner to AI Priory Digital Solutions on the IoT and Edge AI side. Today we'll have Alan Jones, founder director of AI Priory, taking us through the Industry 5.0 evolution and will provide snippets in terms of how to implement Industry 5.0 in the era of Industry 4.0. Alan has been the chief data officer for Konecranes for a number of years with over 30 years of experience in the field of data. He has extensive experience in the areas of ports, ecosystems, manufacturing, and supply chain. Along with him, we also have Dr. Greg Bolela, CTO and co-founder of Digitized Solutions, an Edge AI Alliance partner to AI Priory. He has been a CTO, scientist, and researcher of more than 30 years of experience, having served as CTO architect for the likes of IBM, Sun Microsystems, and VMware for a number of years. He has extensively been a research scientist working on industrial automation through IoT, Edge, and robotics. He is currently focused on building scalable IoT and edge infrastructures for industrial assets to enable seamless Industry 5.0 level application development. This is going to be an hour worth of seminar. Alan will be speaking for the first 20 minutes, followed by Greg another 20 minutes. Finally, we'll have a 15 minutes of Q&A and conclusion. So welcome everyone with this. I would request Alan to start off from here.
Brief history lesson, which is on industrial revolutions. Um, until we had Industry 4, I didn't realize that we'd had three prior industrial revolutions. To me, industry started in the 1780s and has progressed uh, over time using different methods, different power sources. And the interesting thing is every 100 years we had a big change. In 2010, we had Industry 4, and 10 years later, we started talking about Industry 5. And Industry 4.0 is essentially digitizing manufacturing and operations, um, where the world of digital and physical start to converge. More automation, in theory, faster decision making, though I might argue it sometimes confuses as much as helps, and more efficient through production, and particularly aiming for mass production. Some of the issues that we see with Industry 4, um, there are a number. As I said, it's really aimed at manufacturing, making things faster, more quickly. But then you've got the operational costs of capital for buying the big machines. There is too much data. The data isn't always in the right place at the right time. There is device management issues, which I think Greg will cover later. General lack of trust between parties. How can I trust that the data that I have in my systems is real? Provenance, lineage is an issue. Add on to that, we've had layers of data protection. And probably the most interesting change is that the alienation of the employees has increased, because these processes happen, things happen without much intervention from the human side. So what Industry 5.0 at one level aims to is to bridge the gap between the creative capabilities of humans and the efficiencies of machines. Um, the machines aren't going to take over. I hope that in the future the machines and the people will work together. And it's aimed at supporting people, not superseding us. There's been a lot of press about ethics, about job losses. I think this is a reaction to that, and it has to be made to be more human orientated. To put it very, very simply, Industry 4.0 is about the smart factory, it's about mass production, it's still driven by electricity. In the past, it's fossil fuels. In the future, it's going to be renewable. And the technologies are the things we've been talking about for the last 10 years of IoT, cloud, big data, robotics, and AI. Industry 5 looks at much more what's known as a bioeconomy. This is products and processes which are more sustainable. And the other motivation from for Industry 5.0 is personalization. I won't touch too much on that because it's quite an interesting generalized topic. But the ability to have personalized, mass-produced products is something which I think we're going to see in the future. As I mentioned before, it's going to be much more driven by automation, robotics, AI, and then going into cybernetics and this human robot coordination. The end effector is how that's going to be. And all of this is to blur the physical and the cyberspace. It did happen. It started to happen in 4.0, and it will continue to happen in 5. Where I think the difference is that the analysis and the integration and the technology used will get better. So data will still be collected by sensors, it will still be accumulated as what we know as big data, i.e. large amounts of data residing somewhere, but the integration will be a lot better and a lot more simplistic and require much less input from humans. So the technology which we're going to focus on it is roughly in 2 areas. One is to do with sensors and connectivity and networks and artificial intelligence. And why has this happened now, I think, is part that there are other things which are driving the world at the moment, such as the pandemic, labor shortages, and the desire to be more sustainable. That then leads to needing more transparency and need for greater flexibility to respond more quickly as things change. Greg will cover the sort of the physical side, the connectivity. A few words about artificial intelligence. And here we're talking about AI in not so much the classical sense of logic and deductive reasoning, but more the modern AI, which is based on inductive learning and using techniques as neural networks. At the moment, to achieve this, we have to label our data. And to do that, we need some people, we need some technology, and we need time. Unfortunately, not everybody is a Google or an Uber with limitless, seemingly vast, limitless budgets, an army of PhDs just waiting to be deployed in the field. The key question is, how do we do this in an affordable manner? Because at the moment, this is one of the areas which is, it's a big gap between what is expected and what is available. And at the moment, this is where we seem to be sitting a lot in explaining and helping companies look at the data they have and turn it into something which can be used, something which can be used in AI. And to take an example from the wind industry, there are a lot of turbines being built. They're being built by multiple people. The evolution is very, very fast, and the software which is driving these or controlling these machines is also evolving very, very quickly. And we've been working with projects whereby we've been looking at how we can see what data comes from which machine, and then building a data platform that will take that data and say, okay, yep, we recognize that this is machine type A from supplier B with version software C. And then being able to then automatically take that, label it, understand it, add the metadata, and then store it later so it can be used by the inductive learning systems. And I feel that's where industry 4 and 5 start to blur, just like in the past where steam engines took a lot of their technology from water mills. It's an evolution, not a revolution. And the idea that it will stop and change is not so much where we're thinking. What we're thinking is that this is going to be an evolution, and we'll be able to provide data where it can be going to a standard BI practice now. It might then go into some automated system in the future, and then in the later future, there is an autonomous system which can then act on that data, bearing in mind that it probably will build into a cognitive system going forward. Okay, thank you. Sorry, yes. So labeling data is really important, and we need to understand that this is probably one of the key activities that you'll have to do in the future. And at the moment, it's very expensive because it's reliant on people to do it. The technology is not there yet, and it takes some time. So whilst I was supposed to talk for 20 minutes, I seem to have got through it in a bit sooner. So Greg, could you take over now for us?
How's that? Does that look good?
Yes, looks good.
Okay, good, thanks. Thanks, Alon. So what I wanted to talk about today was two areas where, as my experience of working as CTO for IoT at VMware, that I ran into over and over again with CIOs and CIO teams of large multinational corporations. And this sort of reflects that IoT, it was kind of it started out as interesting experiments. It moved on to proof of concepts and some very interesting demonstrations of connectivity between remote-based sensors and computational systems that could do analytics. And it got a lot of people excited. And if I think back in my career, the 2014, 2015 IoT hype cycle was probably the third time we've, as an industry, gotten really excited about this. First time being in the late 90s, and then in the middle aughts, and then in the middle teens. And in each time we learned a little bit more, and each time we sort of had to go back to the drawing board and figure out why the world just didn't IoTify everything. And I think that, what I'd like to bring to this discussion is my experience of two of the things that I found were really causing the delay of widespread adoption of IoT technologies as envisioned by the sort of Silicon Valley crazies out here. I know IoT's been actually happening under the covers in many guises, but I want to sort of address the broad, wide-scale adoption, which is what we need to make sort of a real vertical. And before I start on those, I want to pick up on one thing Alan said, data provenance and labeled data. I've been sort of, that's another thing I've been beating the table about for years is if you look at IEEE 1451, that's been around for, that's a standard that's been around for quite some time. They talk about data provenance and what they say, it's electronic transducer data sheets. So transducers are sensors. They take physical quantities and turn them into electrical signals. So that's where the transducer in the title comes from. And the data sheet for a sensor is incredibly complex and long. I mean, when we started some of our early experiments in IoT, we had these small thermistors, right? They're about 2 millimeter square chunk of plastic with a couple leads on them. And that's it, right? And they just change resistance based on ambient temperature. The data sheet for that component was 40 pages long, not kidding, and full of graphs about response curves and error conditions and accuracy, and all of these issues about how a sensor measures something and what it is that it measures and what is the range it measures and what is its accuracy and how long has it been in service. All of those can be very important to some computations. Now, if you're just measuring temperature in a house, you don't really care too much about that. Close is good enough. But if you're trying to control the temperature in a chemical reaction chamber or a rocket engine, that becomes very critical as to what the error bounds are on the accuracy of a particular sensor. So this metadata that has to accompany the datum itself is really crucial and completely overlooked by most IoT solutions today. I'm kind of fond of saying if a piece of AI or analytics engine gets the number 42, what is it? What does it represent? I mean, just a simple thing like units. Temperature isn't good enough. Is it Kelvin? Is it centigrade? Is it Fahrenheit? And for decades, that kind of information about a datum has been encoded in logic and not in metadata. And that makes logic very brittle. It makes sharing that datum, next to impossible and to get things correct. This became very clear in one of the NASA failures on Mars when the device that measured altitude over Mars and the device that started the rocket engine to break the descent had miscommunicated on units. One was working in feet and the other meters, and resulted in an accident. And so just having this metadata come along and be tightly coupled, maybe even coupled through some non-fungible token in a blockchain is crucially important to the correct execution of analytics and the correct sharing of data. So, okay, on to these two problems that I want to talk about. The management of large distributed remote compute plant and finding a single point of contact that can do end-to-end solution for IoT. Okay, let's see if I can flip slides here. So IoT is getting to be everywhere. It's sort of buried in bespoke solutions in all industries, and it's like Ellen said, it's an evolution, small incremental changes, but not the rapid explosive growth that we've come to know from the tech industry. And one of the observations that we made early on was that even though that all of these industries are introducing IoT solutions, there's the sort of the mobile phone revolution kind of influenced this in a big way. And in fact, many of the early 2014, 2015, people were talking about the mobile phone as IoT gateways, which, ultimately doesn't make any sense. But for some applications, for personal sensing, it does make a little sense. But one of the big differences between a mobile phone and an endpoint in an IoT system is the mobile phone is attended. It has a 24/7 dedicated IT person solely tasked with making that thing work correctly, and that's the owner of the phone. And that may sound like a trivial thing. It may sound like, oh, of course, that's obvious, but it really has a fundamental impact on the management software for that. And if you look across these industries, they and the tech industry were slow to realize that difference, and caused all sorts of problems on the management side. So if we look at sort of a typical edge infrastructure strategy, at the bottom you have sort of devices which are producing some sort of data about their operation. The next level up is a crucial component that tends to be somewhat overlooked with the way people, in the way the tech industry kind of looks at deployment. But in Industry 5.0 and industrial settings, that next level up, known as IoT gateways, is pretty crucial. And these are the sort of the bridge between the sensor industrial automation world and the tech world. And so IoT gateways have to have many different communication protocols to be able to communicate with the devices and collect data from those devices on one side. And then on the other side, they have to be, fully internet enabled, right? Full TCP stack, all the security that goes along with being an endpoint on a corporate internet or on the wider internet itself. The next level up is kind of if you have a lot of data, if the data volume is large, the dominant cost in deploying an IoT solution is going to be networking costs. And so there's a move for these high volume applications like video for compute to move closer to the production of the data simply because of the volume. We see a tremendous interest in video analytics in airports and ports. You can do quite a bit of interesting analytics about streamlining those operations with video analytics. But if you think about a modern airport and how many video cameras it might have, from even analyzing carry-on luggage to all of the planes, where they are, and the service vehicles, you rapidly realize that paying to move all that data to a cloud or a centralized data center just doesn't make sense. It sort of overwhelms the ROI of the solution. And so putting server class systems in a data center on the airport just makes a lot of sense in terms of cost effectiveness. Overall, eventually then, the results of that computation need to be moved into the cloud for cross-airport storage. I know that I've talked to companies that do the IT management for over 800 airports in the world, and of course they want to look at the data and see how they can do better, and sort of analyzing that summary data, if you will, requires a cloud-based solution. So I talked to a few customers, and 500,000 IoT gateways distributed over a large area isn't out of the question. There's an electrical distribution organization that owns the high tension wires and operates them across the northwestern quarter of the United States. And they think they need probably, based on the current technology, over 1 million gateways to cover their lines and their stations and substations. 1 million IoT gateways scattered across a quarter of the United States. I mean, that's a huge compute plant. And how do you address that in terms of management? Energy provides an interesting additional complication to that. I've talked to some of the oil and gas companies, and in trying to look at deploying IoT solutions on their pump sites, you're looking at deployments in 100 different countries and hundreds of different network providers, whether they're cellular or wired. And so the task of maintaining that compute plant across all of those nations becomes a gigantic one. And now the way things happen, they sort of broken down and do things on a field by field basis. Marine ports and shipping ports, again, probably there we have the issue of high data volumes and concentrated in a small area. So really, what's the management problem? Well, if you have 500,000 compute systems, and ultimately these are just Linux systems, and so they're open to all of the issues that any Linux system on the internet or on a corporate network is open to. And how do you patch these in a timely way? I mean, just simply OpenSSL comes out with a critical security vulnerability. How do you get these all patched in a timely way to ensure the safety and the cybersecurity of your enterprise? That's a huge task, and as of right now, there's no way to do that in a seamless way across all of those geos, across those wide variation in communications capabilities and protocols, and even different systems, right? Because over time, an organization is not going to deploy identical IoT gateways across their whole plant. There'll be differences, and so all of that needs to be considered in updating. And one of my kind of favorite cybersecurity goof ups was a casino had their VIP data exfiltrated by an attacker, and the attackers got in through an internet connected thermometer in a fish tank. And that's a real example, and you can understand what happened. I mean, the fish tank people kind of convinced the CEO that fish relax people and they spend more money, so they put fish tanks in the casino. And the operations people of the casino wanted to have some idea of how many fish, what's the replacement cost of the fish, how often are they going to die. And so the fish tank people had to keep track of the temperature, and so they just they had an internet connected thermometer that they bought somewhere, and they asked somebody what the password for the Wi-Fi was in the casino, and they got it. They threw it in there, and they're using that. But that's an unmonitored Linux system on the internet, on the corporate Wi-Fi, and the login passwords were the default on that thermometer, and so it was hacked almost immediately. And so the enterprise CIOs of large companies want to have enterprise quality solutions and have control over what access points are on their network. And that's a really difficult situation when you have many different components that make up an IoT solutions, from the firmware on the sensors, the gateways, all of the software on the gateways from different vendors. I mean, that an IoT gateway, although remote and unattended, is a full-blown compute system, and everything applicable to those systems in the data center is also applicable to the IoT gateways. And the difference being that their remote location requires almost 100% perfect remote management. Many times CIOs would say, how often do I have to send somebody out to reboot one of these gateways? If that's significantly more than never, the ROI of the IoT solution is just swamped with those sending a human out to just reboot the gateway. So the second issue that's come up quite a bit is how does this is in particular was an oil and gas company that I worked with. They had a simple ROI, a simple IoT solution with good solid ROI. They needed to deploy a camera at every one of their pump sites, which were about 500,000 worldwide. And they worked in many years trying to put this solution together and never could come up with a set of components that were all enterprise ready and that could be installed and configured in such a way that they were comfortable with the warranty and the service and the support that they could get from a vendor. And they never really, it's really unfortunate. It was such a really good solution and really simple, but they never did get to put the pieces together that met sort of their enterprise quality. And one of the one of the underlying issues is that we've sort of siloed everything in the deployment and the realization of compute in the industrial and building settings. And this was by nature. This was all we could do. This was the way it had to happen. But it resulted in silos everywhere. And also the lines of business deploy solutions like in that casino example, you know, IT wasn't even involved probably in the fish tank decision. And so that you get these compute solutions deployed with substandard cybersecurity practices that cause problems. And so this siloed nature, the deployment by lines of business, just reduces the ability for these systems to connect and for IT to have a view of the current state of the system and its vulnerabilities. And so this is how it looks, you know, all these separate systems, they work fine as individuals, but when you try to, when IT or when cybersecurity folks tend to take a look at this, there's all sorts of issues in the fact that there's no visibility across them. And so part of the trend and what we're trying to get to in Industry 5.0 is sort of a seamless view of the networking and the protocols and the visibility and the management across all these components for large enterprises. So I think that the two main things that are going to be important in the future, an edge AI platform, something that's rapidly deployable and can be programmed quickly to produce actionable results that result in a solid measurable ROI for an enterprise. And the next thing is the remote operations. I mean, we've had remote operations for many years, but because of the pandemic, people are really starting to think that this is going to be the next generation of IoT. To be able to interact with the physical world across a network instead of being physically local to the machines. And the best example of that, of course, is the Martian rover. And that's when you introduce an 8-minute time lag, one-way time lag between your device and the operator, it makes things really interesting and slows things down. But you know, NASA and other space programs have been very successful with this. Robotic surgery is starting to happen, and drones are really an interesting case as well. The civilian application of drone technology, I think, is poised for rapid growth. There's one company I know that's sort of secretly buying up all the low altitude air routes in major urban areas for drones, and they're already sort of staking out those aerial highways, if you will. And finally, the oil and gas example I gave is indicative of a significant problem in visibility across your whole compute plant when you're talking hundreds of different countries and many different protocols and carriers and networking suppliers. it just really, the complexity here is dramatic, and we need to solve that. We need to solve that. Okay, so that's it for my section, and I'll hand it back to Ellen to kind of wrap things up around 5:00, and then we'll go to Q&A.
Okay. Thank you. Okay. Right. Few words about ports and the maritime industry and Industry 5.0. And please, those of you who are from the ports and maritime industries, I do like you. But it's going to get a little bit choppy over the next few minutes. The first thing that I'd like to talk about are KPIs. Personally, I don't like KPIs because they measure and they analyze things in an attempt to show some level of control and understanding. A lot of companies fall into the trap of measuring the wrong things, which then leads to dysfunctional behavior amongst its employees to get the KPI right. And KPIs only have 3 states, red, green, and the other one. And it's not helpful. You need to understand what drives the KPI. You need to be able to look at what features affect that KPI. You have to look at outcome-based. As an example of outcome-based, something in safety. Bulk carriers, cargoes move during the voyage, not merely because of they're on a big piece of water, but temperature and humidity can affect the way the cargo moves. And if it sort of slips to one side and then the moisture level changes, it can stay like that, causing the ship to list. It's going to be very easy to add an IoT solution, which is to put some sensors in there, some cameras, and then measure something. You then have a state which is going, an alarm is raised. And this then brings to the question of what does the human do? The human in the loop will be taking the temperature measurements. The human on the loop will be sat on the bridge having an alarm flashing that, hold 3 is causing a list. Human out of the loop is that there will be something that the ship itself will take action, either by changing the humidity, changing course, doing some minor thing which it's allowed to do to try and rectify the problem. Or it might be able to work out what's going on earlier before the alarm level, which is usually set at a particular threshold. And again, this then brings to the idea that humans should be allowed to change something simple. The worst thing you can have is a fully manual system, and the worst, the other extreme, is a fully autonomous system. In the number of international space stations, a few missions have been aborted because the autonomous system couldn't quite line the 2 docking channels up correctly. If the human was allowed to make minor adjustments, then the mission could have proceeded. So it's a case of working together. Finally, we are all in a supply chain, and the supply chains over the last year have become greatly scrutinized. People didn't even know they had a supply chain, and we need to ask questions more along of, when will I get my stuff, rather than where it is. I don't care that it's in a container in Southampton. When will it arrive? And to do that, each of the people, each of the links in the chain will have to collaborate more. You will have to share more data. You'll have to trust each other. And whilst this was available in Industry 4, it really just caused a lot of activity about how to defend our business position. We then saw licensing of data, accessing data, data protection reasons, or other people took the other alternative, which was to say, let's monetize the data, let's sell it, which isn't about, that's not collaboration, that's market. And I think that in Industry 5.0, I hope will re-establish the trust between organizations and to understand that you do need to share data so that a retailer can know with reasonable accuracy when he can put the new goods on the website because they've left the factory in, say, China, and it's going to be 6 weeks, 8 and 3 days and 4 hours before that hits his warehouse to be shipped. And this is all about, and that's not just about using the data, but it's about the location of the data, as Greg said, where it's processed, and which pieces of data can be moved between organizations. And now my pet diagram is we're all in this horizontal value chain, which is I supply a service to somebody else who supplies it to somebody else. And it could be particularly in ports that you've got ABB control systems on pieces of equipment, on ships. You've got multiple vendors supplying you with different pieces of equipment. You've got your own maintenance system, which might be then outsourced to third parties. All of this data is usable and useful. And to get the most value out of it, you have to share it. However, you've then got the vertical value chain, which is your own operation, which says, no, we need to have so much return on investment. We need to have this. And that is where I think companies will need to reevaluate their business models and how they cooperate and collaborate with third parties. A while ago, we did mention people, and I think that the workplace will also change for our employees, your employees, in that digital orientation will increase. We will automate simple repetitive tasks, either by using software or by using machines. We've got this idea of that always being connected, I want this in real time. We'll define real time. We're moving towards true real time. We're looking to add value through service products, and the worker needs knowledge, technology, and tools. And I think really importantly is that they need a new set of skills. This is something that we came out with when doing projects for other companies, is you give somebody the answer, what you think is the answer, and they have no idea what to do with it. They can't read graphs. Their software skills aren't good enough. They've done this for the last 50 years like this. Why should I change? You've also got the idea about security. Security is now it's being moved to the edge of your organization, which is your frontline people. You've got process engineering, so to understand that what I do here affects people up and down the line. And just because I make it simple for me by ticking 3 boxes always and just getting rid of it, you have to understand the implications later on. So it's a training issue, which I think we all need to review. So in summary, data management will need change. We need to have more simulation and modeling. Systems need to be more intelligent, more autonomous. Today, tomorrow, they need to be more cognitive, which means they'll be able to think and react and learn themselves. And then we need to facilitate end user actions. And again, whether that's a user going to do something or a machine doing something, that's the ultimate end of 5.5.0. So in summary, 5 builds on 4's foundations. So the things that you do today, providing you understand the aims of 5, should be still viable in the future. There are going to be new ways of working. That's not only for people, but also for organizations. We need new approaches to technology, i.e. merely creating a load of data, putting it in a data warehouse is no longer good enough. So I would say that it's possible now to look to Industry 5, even if your journey in 4.0 is yet to complete. Thank you very much. I'll hand it over to Vijay now for Q&A if there's anything anybody would like to ask us.
Thanks, Alan and Greg. Now it's open for questions. Anyone can unmute and ask questions for Alan and Greg. So we have another 5 more minutes, so we can extend it, not a problem. So please unmute and ask the questions. So any questions from the audience? Okay, so Alan, I have a question which I got it from the group. So let me ask that. So meanwhile, other can join us. So is Industry 5.0 really that different from Industry 4.0? Wouldn't it be better just to carry on as we are? So what are your thoughts, Alan?
In some ways, yes, but I think this idea about making things sustainable and is very important, because seemingly since we've all been locked at home, we are seeing more climate change, we're seeing the using of more resources, and just making things faster and is no longer the answer. And we have to go to circular economies. So outwardly, I would say it looks exactly the same, but I think its aims and its and what's driving it is very, very different.
Okay. So any questions from the audience? Greg, so a question for your side, for you. What steps can the department take to mitigate the management difficulties when deploying IoT solutions?
So I think that there's a couple things that come to mind. One is you have to embrace the heterogeneity of this system. So it's unlikely that you're going to be able to deploy a IoT solution across your whole enterprise and sort of do centralized table-based configuration of these systems. And so look for tools, look for vendors who say, you know, we embrace the heterogeneity, right? We know that you may have different versions of an IoT gateway, versions that, you know, the hardware might evolve over 5 or 6 years, and software requirements, software capabilities are different for each generation. And so our tools look to that and allow you to embrace that and do the right thing for those systems, even though they're fundamentally different from one another. The second thing is to look for vendors who have a high degree of partnerships and interoperability with other vendors. There's very little, I don't know of one company, even the large IoT companies like even GE decided that it was too big for them to tackle the whole thing. And so you're going to end up with lots of different vendors and lots of different components, and what you have to look for is a set of vendors that, you know, potentially are all have alliances and partnerships, and they can work together. And in the way of government contracts, one of them should be the prime, and is the one that sort of you go to and get support for the full system. And so those are the two things I would recommend.
Thanks, Greg. Any questions from the audience before we want to wind it off for today? So the final question from the audience. So you can unmute yourself. So there is mute, unmute. You can unmute and ask the question for Alan and Greg. So Alan, right? So you can do a final conclusion statements, and we can call it for the day.
Yeah, I think. Yeah, I think we've said everything.
Yes.
But probably we should now say that this idea of having a data platform is something that we're actively pursuing.
Yes.
To see if we can get the heterogeneity which is inherent under some sort of control, and then that is then to be able to be fed through to the rest of the enterprises.
Okay, thank you. So this session is recorded. So after this, we will share the recorded version to all the participants. Thank you all. Thank you everyone for joining us. Thank you,
Thanks for
Alan.
coming.
Thank you.
Thank you.
Thank you all.